Welcome to the channel, and today our subject of discussion is color change, another very important paint defect. Our discussion will include definition of color change, illustration and photograph, interpretation of action priority levels, causes and a countermeasure, including the explanation of the terminologies like blue wool scale, spectrophotometer, and calibration of equipment. Infographic related to causes and countermeasure, repair method, and finally introduction to the next topic. Color change refers to a visible deviation in the painted surface original color occurring over time due to environmental or chemical exposure. Though automotive coatings are designed to be light, fast, and durable, prolonged exposure to UV radiation, heat, humidity, or chemical pollutants may lead to fading, yellowing, darkening, or discoloration, as shown in these two photographs. The action priority levels shown in the causes and countermeasure have three distinct marks: red, yellow, and green. Red are the immediate action required, that is, these causes are critical and directly linked to higher customer complaints, durability risks, safety, or warranty costs. Therefore, must be countered with urgency. The yellow, the yellow causes and countermeasure are to be monitored and to be improved. These are medium priority causes that can grow into serious issues if left unchecked, improvement or process checks required. The greens are low risk causes. These are ideal for operator awareness, SOP reinforcement, or occasional audit. Now, coming to the causes and countermeasure related to color change. Number one is UV exposure. It is a top priority action, and the cause is long-term sunlight, exposure to long-term sunlight. The recommended countermeasure is use UV resistant top coats, apply stabilizers, and ensure proper clear coat coverage. The second important cause is low-grade pigments. These are also action priority items. Use of inferior pigment quality, and the recommended countermeasure is use automotive grade pigments which is greater than or equal to blue wool scale. Inferior pigments degrade under light, causing fading. The blue wool scale is a standardized method to measure light fastness, that is, how resistant a pigment or dye is to fading when exposed to light, especially UV rays. The scale is from 1 to 8. 1 is very poor light fastness, that is, it fades quickly, and 8 is excellent light fastness, that is, barely fades over time. In automation or industrial paints, pigment with the rating of 7 or 8 are preferred and therefore recommended. Blue wool scale is used for evaluating pigments in automotive coatings, textiles, inks, and paints for outdoor quality. Third important cause of color change is clear coat degradation. Deterioration of clear coat exposes color to UV rays. Breakdown of top coat, clear coat layer, and the recommended countermeasure for it is ensure proper thickness and UV absorbers in a top coat. Number 4. Heat and humidity is another important factor which contributes to color change. Prolonged exposure to heat and moisture. Heat and moisture accelerate breakdown of pigments. Therefore, use heat-resistant coatings and simulate aging tests. The fifth important cause of color change is acid rain and pollution. Atmospheric pollutants affect painted surfaces. As acidic acid react with paint films causing blotching. Therefore, apply hydrophobic layers and improve acid resistance. Mismatched refinishes. This is the sixth important cause responsible for color change. Poor color matching during repair. Poor matching causes visible contrast under light. Therefore, use spectrophotometer, blend adjacent panel properly. Spectrophotometer is a precision color measuring instrument that detects and quantifies how light affects of a surface at different wavelengths. It is used for exact color matching during refinishing or touch-up. It ensures paint blends seamlessly with adjacent panels. It reduces human error in visual color assessments. It is used in auto paint shops. That is, operator places the device on the painted surface. The device scans and gives a digital color formula to match. Seventh important reason of color changes: incomplete curing. Incomplete curing of paint film. Under cured paint film results in early oxidation and shift. Therefore, ensure proper curing cycles and monitor oven temperatures. Number 8. Number 8 important reasons of color changes: application variability, that is, inconsistent paint film thickness. Varied thickness affect UV protection. Therefore, calibrate spray equipment to maintain uniform coating. By calibration of spray equipment, we mean it is to calibrate spray equipment, adjusting the spray gun setting to ensure consistent paint application. This includes nozzle size, appropriate for paint type and viscosity, air pressure, match to gun specs and finish requirements, fan pattern, even coverage across the spray width, material flow rate, avoids over and under application, distance and angle, ensure uniform film thickness. It is important to prevent issues like color mismatch, orange peels, runs, or thin film. It ensures that UV blockers and pigments are evenly distributed. Ninth important reason which may contribute to color change is chemical spillage. It is comparatively a lower priority, that is 6 by 10. Contact with aggressive chemicals. The aggressive chemical or fluids may bleach and discolor the paint film. Therefore, improve chemical resistance and educate users. Number 10. The number 10th reason for the color change could be sunlight exposure. Sunlight exposure during storage. Sun exposure during storage fades paint. Therefore, use UV protective covers or films during storage. Here is the infographic related to causes and a countermeasure and ranked from 1 to 10 along with action priority, as we have discussed just now. How to repair the color change defect. To start with, initial evaluation, that is test compounding. Select a small affected area and apply a rubbing or polishing compound. Buff it gently to determine whether the original color is restorable. If color is restored, proceed to compound the entire discolored area to remove surface staining and restore its uniformity. And if color is not restored, compounding is ineffective, proceed to the following refinishing process. Wet flat sand the discolored top layer using appropriate grit, that is P1500 to 2000. Thereafter, respray the color coat followed by a clear coat application as per standard refinishing procedure. With this, we conclude our today's discussion on the subject of color change. Our next topic is defect number 13, that is color mismatch. Thank you and thank you very much.